Everything you see, touch, or even breathe is made of matter. From the air swirling in the room to the water in your glass, matter is everywhere. But what exactly makes matter so unique? In this video, we'll take a fun and simple journey to discover the fascinating properties of matter. Get ready to look at everyday objects like a balloon, an iron rod, or even a splash of perfume in a whole new way. Let's dive in and uncover the secrets that make up our world one property at a time. What is matter? Matter is anything that has mass and takes up space. That means if you can weigh it and it fills up some room, it's matter. At the tiniest level, matter is made up of particles called atoms and molecules. These particles come together in different ways to form everything from a drop of water to a sturdy chair. Remember, if it has mass and occupies space, it's matter. This simple rule helps us identify matter all around us, from the biggest mountain to the smallest grain of sand. Let's look at a simple experiment. When you add sugar to water, it seems to disappear. But what's really happening? The particles in water have tiny spaces between them. Sugar particles slip into these spaces, which is why the sugar dissolves. This property shows us that matter isn't just a solid block. There's space between the particles, even if we can't see it with our eyes. This is why many substances can mix or dissolve in others, making everyday life possible. Have you ever noticed how the smell of perfume spreads across a room? That's because the tiny particles in matter are always moving. This constant movement is called diffusion. It's why smells travel, why ink spreads in water, and why gases mix so easily. Even in solids, particles vibrate in place. This movement is a key property of matter and helps explain many things we see in daily life, from the way smells travel to how heat spreads. Another amazing property of matter is that its particles attract each other. This force of attraction is what keeps substances together. In solids, the attraction is very strong, which is why solids keep their shape. In liquids, the attraction is weaker, so they can flow. In gases, the attraction is weakest, allowing them to spread out and fill any space. This property helps explain why different materials behave the way they do. Start with solids. Think of an ice cube or a metal rod. Solids have a fixed shape and a fixed volume. That's because their particles are packed tightly together and can only vibrate in place. This tight packing gives solids their strength and structure. Whether it's a rock, a wooden block, or a piece of metal, all solids share these basic properties. They don't flow or change shape easily because their particles are held firmly in place. Now let's look at liquids. Imagine pouring water into a glass. Liquids have a fixed volume, but they don't have a fixed shape. Instead, they take the shape of whatever container they're in. This is because their particles are close together but not as tightly packed as in solids. They can slide past each other, which lets liquids flow and change shape easily. From milk to juice to oil, all liquids behave this way. Gases are a bit different. Think about the air in a balloon or the steam rising from hot water. Gases have neither a fixed shape nor a fixed volume. Their particles are far apart and move freely in all directions. That's why gases can fill any container, no matter its size or shape. This property makes gases unique and explains why air spreads out to fill a room or why scent travels so quickly. In solids, the particles are arranged in a very orderly and tight pattern. This arrangement keeps them locked in place, which is why solids keep their shape and are often hard. The particles can only vibrate slightly, but they don't move around. This structure gives solids their strength and makes them difficult to compress. In liquids, the particles are still close together, but they're not as tightly packed as in solids. This allows them to move around and slide past each other. That's why liquids can flow and take the shape of their container. The particles are not arranged in a fixed pattern, which gives liquids their flexibility and ability to pour. Gases have particles that are far apart and move freely in all directions. There's a lot of empty space between them, which is why gases can be compressed easily and can expand to fill any container. This random movement and loose arrangement make gases very different from solids and liquids. When a solid is heated, its particles gain energy and start to move faster. Eventually, they break free from their fixed positions and the solid turns into a liquid. This process is called melting. For example, when ice melts, it becomes water. Melting is a common change of state we see every day. The opposite of melting is freezing. When a liquid loses heat, its particles slow down and come closer together. Eventually, the liquid turns into a solid. For example, when water is cooled, it freezes and becomes ice. Freezing is another everyday example of matter changing its state. Evaporation happens when a liquid turns into a gas. When you leave water out in the sun, it slowly disappears. That's because the particles at the surface gain enough energy to break away and become gas. This is why puddles dry up after it rains. Condensation is the process where a gas turns back into a liquid. You can see this when water droplets form on the outside of a cold glass. The gas particles lose energy, slow down, and come closer together to form a liquid again. Sometimes, a solid can change directly into a gas without becoming a liquid first. This process is called sublimation. A common example is dry ice, which turns straight into carbon dioxide gas. Sublimation is less common, but it's a fascinating property of matter. Deposition is the reverse of sublimation. Here, a gas changes directly into a solid without becoming a liquid. Frost forming on a cold window is a good example. Water vapor in the air turns directly into ice crystals, skipping the liquid stage. Physical properties are characteristics you can observe without changing what the substance is. Appearance is one such property. It includes things like color, shape, and texture. For example, gold is shiny and yellow while wood is brown and rough. These features help us identify and describe different types of matter. The state of matter, whether it's solid, liquid, or gas, is another physical property. You can see and feel the difference between ice, water, and steam. These states depend on how the particles are arranged and how much energy they have. Density is a measure of how much mass is packed into a given space. For example, a rock is denser than a sponge because it has more mass in the same amount of space. Density helps explain why some things float and others sink. It's a key property for understanding materials. Solubility is the ability of a substance to dissolve in another. For example, sugar dissolves in water but sand does not. This property is important in cooking, cleaning, and many scientific processes. It helps us understand how substances mix and interact. Every substance has a specific temperature at which it melts or boils. The melting point is when a solid turns to liquid, and the boiling point is when a liquid turns to gas. For example, ice melts at 0 degrees C and water boils at 100 degrees C. These points help us identify substances and understand their behavior. Conductivity is the ability of a material to allow heat or electricity to pass through it. Metals like copper are good conductors while rubber is a poor conductor. This property is important in making wires, cooking utensils, and many electronic devices. Some materials like iron can be attracted to magnets. This property is called magnetism. It's used in many everyday items from fridge magnets to electric motors. Magnetism helps us sort materials and create useful tools. Malleability is the ability of a material to be hammered or rolled into thin sheets. Metals like gold and aluminum are very malleable. This property is important in making jewelry, foil, and many building materials. Ductility is the ability of a material to be drawn into wires. Copper is a good example of a ductile material. This property is essential for making electrical wires and cables. Hardness is a measure of how resistant a material is to being scratched or dented. Diamonds are the hardest natural material while chalk is very soft. Hardness helps us choose materials for different uses like tools or jewelry. Brittleness is the tendency of a material to break or shatter easily. Glass is a brittle material while rubber is not. This property is important when choosing materials for safety and durability. Elasticity is the ability of a material to return to its original shape after being stretched or compressed. Rubber bands are very elastic. This property is useful in making sports equipment, clothing, and many everyday items. Transparency is the ability of a material to let light pass through it. Glass and clear plastic are transparent while wood and metal are not. This property is important for making windows, lenses, and screens. Luster is how shiny or dull a material appears. Metals like silver and gold have a high luster while wood and rubber are dull. Luster helps us identify and use materials in jewelry, decoration, and art. Odor is the smell a substance gives off. Some materials have a strong odor like vinegar while others have none. Odor can help us identify substances and is important in food, safety, and cleaning. Taste is another property, but it's only safe to test with food items. Sugar tastes sweet while lemon is sour. Taste helps us enjoy food and identify edible substances. Texture is how a material feels to the touch. It can be smooth, rough, soft, or hard. Texture is important in choosing materials for comfort, safety, and design. Flexibility is the ability of a material to bend without breaking. Rubber and plastic are flexible while glass and ceramic are not. Flexibility is important in making toys, tools, and many household items. Permeability is the ability of a material to let liquids or gases pass through it. Sponges are permeable while plastic is not. This property is important in filters, clothing, and packaging. Viscosity is how thick or thin a liquid is. Honey is very viscous and flows slowly while water is less viscous and flows quickly. Viscosity affects how we use liquids in cooking, cleaning, and industry. Buoyancy is the ability of an object to float in a liquid or gas. Boats float on water because they are buoyant. This property is important in designing ships, submarines, and even hot air balloons. Compressibility is the ability of a material to be squeezed into a smaller volume. Gases are highly compressible while solids and liquids are not. This property is important in air pumps, packaging, and many machines. Thermal expansion is when a material expands as it gets warmer. Metal rails on train tracks expand in the heat and contract in the cold. This property is important in construction and engineering. Surface tension is the force that makes the surface of a liquid act like a stretched elastic sheet. It's why small insects can walk on water and why water droplets form beads. Surface tension is important in nature and technology. Capillarity is the ability of a liquid to flow in narrow spaces without external help. It's why water rises in a thin tube or moves up through the roots of plants. Capillarity is essential for life and many scientific applications. Porosity is the measure of how much empty space is inside a material. Sponges and soil are porous, meaning they have lots of tiny holes. Porosity affects how materials absorb water and air, which is important in construction and gardening. Brittleness and toughness are opposite properties. Brittle materials break easily like glass, while tough materials can absorb energy and resist breaking like rubber. Knowing the difference helps us choose the right material for the job. We've explored many fascinating properties of matter, from how particles are arranged to how materials behave in different situations. Understanding these properties helps us make sense of the world and choose the right materials for every need. Whether it's building a house, cooking a meal, or simply enjoying a glass of water, the properties of matter are always at work. Keep exploring and you'll discover even more amazing things about the world around you.